All right, so today we're going to talk about solving linear systems, and we're going to do that by graphing first, and then we're going to do that algebraically. So we're going to start with the first part by graphing. So our objective today is to solve a linear system of equations by graphing, and I'm going to walk you through how to do that. So we're going to graph the equations of the lines first. And you want to rewrite them in slope-intercept form depending on the form that you're given. Then you're going to graph both the lines, and then you're going to estimate the points of intersection. So when we say solving linear systems, a system incorporates more than one line, a linear system, so 2 or 3 or 4 lines, and then or more. And when we say solve, we mean to find the points of intersections. That's what we mean by solving a linear system. So we want to first rewrite in slope-intercept form to graph it, then graph it, and then we're going to estimate the points of intersection. And I'm going to talk about different possible outcomes, and this is going to be a topic of discussion throughout this section. It's going to be 1 point of intersection where 2 lines cross, 0 points if the lines are parallel and never touch each other, or an infinite number of points where we have 2 lines that are the same, so they overlap. And then we want to check our solutions algebraically or mathematically by substituting the values back into these equations. So let's go through how you solve a system by graphing. All right, so the first thing that we want to do is we have 2 equations for 2 lines, and we want to graph the equations of the lines. You can see here that it's already set up in slope-intercept form. So I'm going to go ahead and graph the 2 lines. Y is equal to 2.5x minus 3, y is equal to negative x plus 4. So I've graphed them. Remember to draw the lines to the edges of your graph with the tips of the arrows. And then I'm going to estimate that point of intersection as 2, 2. So I've drawn the graph. I've estimated the points of intersection. And then I'm going to check the answer mathematically through substitution. I'm going to take that value for 2, so I'm going to substitute it back in to the first equation. So 2y is equal to 5 halves x minus 3. 2, 2 is the solution, so I'm substituting that back in, and I end up with 2 is equal to 2. So that's the result that you want. You want some equality for both of the equations, and then I'm going to go ahead and try the same thing here on the left-hand side. So 2y is equal to negative 2 plus 4, and I end up with 2 is equal to 2. So I checked out both equations. Those work. Now I've also solved them mathematically here on the right-hand side. So I've taken these 2 equations. This will be the topic of another discussion on solving equations of lines algebraically, but I've done that other work here on the right-hand side for you to check. All right, but we're only concerned right now about checking this graphically. We've identified the point, and then we've checked that out through substituting that point in. All right, so that brings us to your first classwork problem, 1.4.1. And I'm going to give this to you. So you're going to go through the process of you're going to graph the equations of the lines, and then you're going to estimate the point, and then you're going to verify it by substituting it back in. So the same 3 steps that I just went through, that's what I need for you to do. And that's going to be it. That brings us to the end of our discussion for solving systems of linear equations by graphing. You just have this one problem for this first part. Please join us again very shortly as I continue the second part of this section. We talk about solving linear equations algebraically.